if we don't say recursive equals true, if any of the parent directories are missing, then it's going to yell at us and give us an error message. So by saying recursive equals true, if what, like HIV 2023 isn't there, it'll make that. If LANL analysis isn't there, it'll make that, and then it'll make raw data. Does that make sense to everyone? Questions about that? Okay. So let's run that. And so it's saying for me that directory already exists because I actually made that, ran through this before. But for you, it should just make the directory. Okay, so I'm going to make another chunk, which I didn't include here. I had it all together, but I'm going to do it separately for cleanliness or organization. And so now we want to plug in the URL where we're going to be downloading the data. And here, I'm not going to try and type it. I'm going to go over to this tab, and I want to right-click on the download data, if you can do that, and then copy link address. You can also do control-click usually. That'll work. If anyone's having trouble getting that menu, let me know. Cool. I'm assuming that the silence means it's working well for everyone. And now I'm going to put double quotes in, and then I'm going to do a paste, which on a Mac you can do Command V, on a PC you should be able to Control V. And so you should have the same URL there. And then the last thing we need to do before we actually download it is we need to tell it where so the function in R that we're going to use to actually download that file, it wants to know where you're going to save the file to. And so we're going to use a little bit of code to make a file name for us. So we're going to use a pipeline here. We're going to take that URL as a starting point. And basically, we would just want to grab this little bit here. And we could just do this by hand, but I find it's nicer to actually let R do it for us. So we're going to pipe that to a function called base name. And what base name does is it's going to strip off everything except the file name itself. So when we run that, you'll see what we get out is just the file name itself. Okay? And then the next thing we're going to do is we're going to give this actually a directory to put it in. And for that, we're going to use file.path, and that we're going to put it in that data directory that we just made. And because we're using a pipeline, normally in dplyr with pipes, it puts the argument that's coming from the previous step, it plugs it in the first position. But for file.path, we want that to be the directory. So we want that file name to go in the next position as an argument. So we can put a dot there, and that tells dplyr, okay, that's where we want what's coming from the pipe to go. Does that make sense? And then now we're just going to assign that to a new variable called LANL zip path. And now we can run that, and you'll see that's coming. So this is where it's going to be. It's going to be the same file name as the URL, and in that directory, that data directory. And so I like doing it. It's in some ways a little bit more complicated doing it this way, but it does make it a little bit more reproducible, because if we end up changing the URL, but we don't change the file name where it's being saved, then things can get confusing. That makes sense? Questions about that? Everyone kind of get where we are? And should I make this bigger? Anyone
That
want
was
me?
helpful for me.
Okay, sorry.
I've been able to manage so far.
No, but yeah. I think it popped in my head for a second and then I popped back out. So is that good? Bigger? Okay. Yeah. If you haven't learned by now, yell if you want, like, if there's a problem. Because I'll just sit up here and keep talking. I'm in my happy space, so I'm good. Okay. What?
This says object path not found. What is
Ooh, object path not found. For which?
when I'm running the.
This chunk?
Yeah, that chunk.
So there, that should be a dollar, I mean, percent, greater than percent, instead of that's a right, this is a right assignment. You want a percent, you want a height.
Oh, okay, so I have moved that back.
Oh, I
only
see.
had it,
Okay. Oh, so then if you want to put it there at the beginning, then you just need the assignment operator to it.
So can
You gotta get rid of the, you need another. Should I make it bigger? Actually, looking at it here, there it looks really big. Here, that's. Make it bigger. Is that readable? Pretty good. Okay, any other questions, comments, confusions? Okay. So, okay, so now we kind of like got everything ready, like cooking show, we got stuff to go into the oven. And now we're actually gonna download it. So we're gonna use a function in R called download file. And so download file is kind of like the R version of like clicking on a link and downloading it. And so we're going to do download file. And then the first argument it's going to want is the URL. And then the second argument it's going to want is we can use the name arguments or not. The second argument that it's going to want is the file name to save the file to. Everyone got that? And then if we run it, hopefully the server doesn't crash because we're all downloading the data at the same time. Okay, and so it should say trying URL, and it should say, the URL that it actually downloaded, and ultimately it should say downloaded 240 KB. Anyone not there? Okay, and then the next thing we're gonna do, and I'm just gonna do this in another chunk so we don't download it again, is now this is a zip file, and the easiest way to deal with that within R is to unzip it. So we just use this unzip function, and we tell it where the file is. I mean, the name of the file, so it's gonna be LANL zip path. And then we can tell it where we want it to be unzipped. And to do that, we say exdir, it's the short for extraction directory. And then we tell it the directory, which we want it to go in the data dir. If we don't tell it this, then it's gonna unzip it in our current working directory, which is not where I want the data. The current working directory is a repo. So I'm going to run that, and it doesn't say anything. What is it? What's it saying? probably that you didn't run the chunk where we made the directory. So if you go back up. Yeah, so add line after that, line, and then dir dot create. And then with and then data dir. And then you need to do first true. You just run the logic. You don't have to hide it, you can just put them there. And they're different.
Thank you.
Okay. Any other questions? Keep going. Okay. Wow. It shocked me. That was very shocking. Okay. So there are a couple of different ways we can actually look what was in there. One option is we can just use the R function, list.files, and plug in data dir and run that. And so there you can see all the files. So we actually like unzipped in the same directory that the zip file is in. So here are the FASTA files, here's the Excel spreadsheet, and here's that original zip file. If for some reason you wanted to like look at it in the R file browser, you could click on the 3 dots there and find your way to the directory. So /work/Josh. Click on this, panel analysis, raw data. So you can see it's here too. Both of them work. Okay, so. Yep.
Okay. All right, thank you.
Okay. So I think that now, let's just set up one more thing for tidiness purposes. Let's set up a path to a few of the files. So clinic, maybe I shouldn't have made you type this. So we're going to work with 3 different files. So we're going to work with the clinic data. And so we will do file.path data dir, and this should be 1362. Actually, you know what? I'm going to just copy it from up here. If I try and type it, I'm going to get it wrong. So we want this 1362 clinical data. And then the next variable is going to be strong selected path file.path data dir, and then I'm going to go up here and find it. I'm going to just copy and paste this strongly selected epitopes and put that there. And then we're going to do one more. And epitopes path get file.path data dir. And for this one, we want the variant ends epitopes, which is here. Okay. And then I'm going to run that chunk just so those actually get defined and plugged into the environment. Okay. So now it's your turn. It's a perfect opportunity though. So I'm going to give you, let's start off with like maybe like 5 minutes. I want you to load the data. So we already had a peek at what it looks like, but I can, maybe I can't. Well, I'm not sure if it's my computer. So here's what the data looks like. I want you to load it into a data frame, and I want you to make a plot of, I think there was one in the paper. I don't think I came up with this on my own. I want you to make a plot, not this, not that. Wait, is it that one? Make a plot something like this, but also with the CD4. Sorry, this is CD4 and viral load. Do CD4, CD8 and viral load. And I will say that if you can figure out how to do this other axis, great. But for now, I wouldn't worry about it. I don't actually know how to do it off the top of my head. I have to go for that. I solved it a different way. Was that clear? And I don't know whether, you'll be able to do this in 5 minutes or not, but we'll see. Questions? Huh?
CD8.
CD4, CD8, and viral load. And I will say that like putting those all together, it's gonna like make for like kind of a messy plot or like there can be some problems with it. We'll touch on that later. Unless the computer blows up.
Can I actually ask, I never download data in this way, how to make a data frame from self-stored on the drive?
Well, so you have, I'm only giving you 5 minutes.
Sure.
So I want to like have you like experience a little bit like the how do you do this? So I'm not going to tell you right now, but I will say that you have the path. We just defined the path to the file. It's that clinical data.xls, the clinical data path. And the question that you want to ask, possibly when I ask Google or ChatGPT, is, since I'm not going to answer it quite yet, is how do you load a Excel spreadsheet into a data frame in R? Okay, I'll walk through how I did it. Okay, so to load the data frame, it's weird, you can't see this is, not highlighting it. Okay, so to load the data frame, I'm going to do clinical data path. I'm going to pipe that to read Excel. So this is a function of the package read XL, which is, we loaded it at the top here. And sometimes this will be enough. So I'm going to run that. And it's actually done a pretty good job for us. It's loaded the data. And we can look here, we got 2 columns, 3 columns, 4 columns. And there's one funny thing. Actually, let me load that as a data frame so that we can look at it in the data frame viewer thingy-majigger. There. Oh no, it doesn't show it here. Never mind. I want to look at it here. Okay. Does anyone notice anything funny here? It's subtle. We got, here are the first 2 columns. Here are the second 2 columns. One of these things is not like the other. What's different?
Loaded character.
Yeah. Viral loads characters. Any idea why it's character? Does it make sense for it to be characters? And look at all these values. Do any of them look like characters? Let's look at the spreadsheet. Does everyone understand why that's weird? Or anyone want me to explain that? Okay, I'm assuming that that totally makes sense to everyone. Okay, let's look at the spreadsheet. Actually, before we look at the spreadsheet, there's what? Where's it giving me the like error thingy ticker? I need to run this again. Yeah. Oh, it's not giving me the message. Oh well. Okay, so let's look at the spreadsheet. Do you notice anything here? And I can make it bigger. So there are these two cells here that got a little green triangle in the top left corner. When I click on those, it says number stored as text. How do I know that? I don't know. I don't know why it's stored as text, but it is. So presumably that's why it's seeing these two, because there's actually like two different ways on the computer to actually represent, well, there's more than two ways, but there's at least two different ways on a computer to represent numbers. You can represent it as text, or you can actually represent it as numbers. And sometimes we kind of flip between those two, and R will kind of flip between those two automatically without you asking sometimes. But here, it's seeing that some of the things in this column are actual numbers and some of them are text. And you can represent any of these numbers as text, but you can't represent any text as numbers. So it's going to default to say, okay, well, that's text, those are characters, so I'm just going to make that whole column characters, because you can't, within a data frame, the columns all have to be the same thing. Okay, so that could create problems for us later. And so one thing that we're going to want to fix is we're going to want to actually make that be numeric column. There's one other thing that's like maybe, not a big deal, but might be more convenient for us, which is like these column names are really long, and I don't know, I don't want to have to type them all. And then spaces, which in R, if you want to refer to them with spaces, you got to use backticks. So I'm going to rename those for now. So we're going to do this one more time. Clinic data path, and we're going to pipe that to read Excel. We're going to explicitly tell it that we want the column type to be numeric. So this will, since all of them are numeric, we can just say numeric and just do it for all of them. And so just doing that, now we have, that's what I was looking for. Now they're all doubles, right? And I was looking for this warning, which says, warning, coercing text to numeric in D17, row 17 C4 and row 18 C4, which if we go back here, row 17 and 18 4. So it was noticing that those were text. Of course, now we know that, and now we're telling it we want those to be numeric. So coercing text to numeric, that's like, it sounds bad and it can be bad, but it just means that you're like forcing something that's text to be a different type, to be numeric. Okay, so that's that. And then the other thing I want to do is I want to rename those, the columns, rename, and so we'll make the first column DPS. I'm going to just go up here and, or no, I guess I don't even need it up there. Just go here and copy this. And again, we need to do, I actually remember if we have to do backticks here, but I'm going to use backticks. And then we'll rename the CD4 count to CD4, backtick. I'm gonna copy that. We'll rename the CD8 count. Actually, I'm gonna be lazy, I'm gonna just copy this line. If you copy and paste, you gotta be sure you do it right. So copy and paste, I'm gonna change the CD4 in both places to CD8. If you do that wrong, you get us in trouble. And then I'm gonna do virus equals backtick. And copy this, the viral load. And now, when I run this again, now I've got this, they're all numeric, and I have these shorter names for the columns. So I'm going to right assign that to clinic data df, and then we'll just print that out. Clinic data df. I've already seen it. Okay. So we have the data loaded. So now let's do some visualization. We can do clinic data df, and we're going to use ggplot for this. And ggplot tends to like things in the long format. Remember when we did tidyr, right, Janice? Yeah. So remember, you know, like long format and wide format. So ggplot tends to be happier if you give it data in long format. So that's what we're going to do. So we're going to use pivot longer. And we're going to say it's going to do all the columns except the DPS column. And then names to, so this is what so it's going to keep the DPS column, and then the other column, it's going to have a column with the values, and it's going to have a column where it says like what type of value that is. So that's the names to a column. It's going to tell us what type of value it is. And so we're going to do names to assay type, and then values to, so this is going to be the name of the column that actually has the values. So we'll call that blood counts. Oops. Sorry, I'm going to split this up just because it's getting too long. And then we'll redirect that to GG. Actually, let's look at that really quick. Let's run that. Okay, so here we're keeping the DPS column, we have the assay type column, and we have the blood count, right? And then we're gonna redirect that to ggplot. And the X value will be the days post symptom onset. Y is the blood count, and then we'll color it by the which value it is. Let's say type, and we'll just do a scatter plot for that. Geom point. Okay, and if we run that, nothing happens. Oh, it's being so slow. I feel like when I was running through this, it was super slow.
Everybody else.
There we go. Yeah, it's not even that much data. I have no idea. It's super weird. Okay, so we have a plot. Yay. Anyone not get here yet? Where are you stuck? Or is it spinning?
Now, renaming the columns is pretty difficult. I'm not sure.
Okay, let me take a look. A lot of typing.
Yeah.
You don't have copy paste.
Well, it is, and I couldn't get this DPS or,
So don't do the, it could be that your problem is that you're doing, you know, that period there.
oh yeah, that's just.
And you don't need, so you.
Well, it actually worked, but the thing is, it didn't, so, okay, the reason that's into there is I just called it call name number one. You know what I'm saying, like, sort of like, DPS equals that.
So you don't need this calling.
You need it, it should work.
Okay, I see you're calculating. Okay.
Right, this
There's
actually.
so I think there's actually another way to do that.
Right.
Because that's kind of a messy way to do it. So I'll tell you the reason why so what he's doing is actually like trying to pulling the column names out of the data frame and using that. So if you just want to do it by like the order, it's actually probably a little bit cleaner to when you do read Excel to give it.
Right, well, so either way, I can't keep it whole, I don't know how to copy paste.
You're saying that.
Right, but I try to do this, space, that's not correct.
Oh,
Right?
you gotta do that.
Backticks around these?
Yeah, so, yep, no, yeah, yep, exactly, yep.
Okay, thank you.
But, the space after that. Yeah, so the reason why I actually put the full name in is because, I always worry that if I try and do it by order, sometimes it's kind of unavoidable. If I try and do it by order, then I'm worried that something will get swapped. So I like to actually do things by name. Is that working?
Yeah.
Okay. Any other problems? Okay, so beautiful figure here. Any issues with it? Anyone have any issues with my beautiful figure? It's perfect in every way. Nobody? Okay, we'll send it for publication. Let's go. I mean, I guess it's already published. Some minor detail. Nobody has any issue with my figure. It's squished to the bottom. You want to explain what you mean?
So we're gonna have to adjust the scale like counts, right? To be able to like see the whole thing.
Possibly, yeah. And is there another problem that actually might, well, I'm not saying it's another problem, but kind of another problem?
Since we're the leave out outlier, is that also?
Maybe, but I mean, that actually might be important. That like the viral load on when the person's first tested is really high, and then I actually didn't read the paper super carefully, but I'm assuming like because it's standard of care now that they got some sort of antiviral treatment, and so it's dropping down. Although it could be that this is, I don't remember how old the data set is. It could be that this patient's actually antiretroviral treatment. So it could just be dropping down because the immune system's controlling it. I actually see one other problem that maybe it's obvious to everyone else. Where's my CD4s? and try to plot 3 values, I only see, or 3 types of data, I only see 2. Any idea where my CD4s went? They're hiding. They're squished out at the bottom here. If you look, there's like the tiniest bit of red, which I can't even see on my screen, but it's really big here. Because this is really the same process. Viral load is on just a different scale. It's a completely different assay. And we kind of could see this with the numbers here, right? CD4 and CD8 counts are like peaking around 1,500. The viral load is peaking around 800,000. So it's just an issue of scale that like the CD4 and CD8 are indistinguishable from 0 on this scale, and the CD8s are plotted on top of the CD4s, basically. Okay, so there are a bunch of different ways that we could fix this. The way that I decided to fix this, which makes things like not too hard, is to do facets on this. So we can do facet wrap, and we're gonna facet it by assay type so that every, like the CD4, CD8s, and viral load are gonna be plotted separately. So if we just do that, then we get a figure like this, where like, okay, that's an improvement because at least we can see the CD4s, but everything's still squashed at the bottom because by default, when you do facets, the scales are the same. The X and Y axis scales are the same, but we can say scales, free Y. I feel like this is like a movie about a whale or something. So now it'll allow basically it'll make the axes how they would be if it wasn't if they were just individual plots, which has its pluses and minuses, right? Because you might say, oh, I want the CD4s and the CD8s on the same scale, but we're doing this like a little bit quick and dirty. So now we can actually like see something here, which I think is a big improvement over what it was before. So that's our plot. When I did this myself, I just made it like a little bit prettier because I don't like the gray background. So I made it theme black and white, which gives us this, like a kind of a white background. And I got rid of the legend here because we got the facets labeled separately, so we don't really need the legend. Theme legend position equals none. And then one last thing, which is a lesson I've learned from someone who has expertise in data visualization, is that you shouldn't waste color. So like here, we have 3 separate plots. Now, there are other ways we could have done this. We could have done it like the figure in the paper and put it all in one plot. But I'm being lazy and having 3 separate plots. We don't really need 3 separate colors anymore. You kind of, the sort of one philosophy of data visualization is you want to save your color for like places where you need it. So I'm going to get rid of, before we were coloring it by assay type, but we don't really need that because we have 3 separate plots. So I'm going to let the points be black. And I think I'm ready to call it a day on that data set. And it's 2:15, so maybe do people want to take a break now, like 10-minute break? Actually, sorry, I lied. I'm not going to give you a break yet, because what I'm going to do is I'm going to say that your next assignment is to struggle. Let's make this like a 15-minute break. And so you have 15 minutes to take a break and also to look at the next data set. I'll even show it to you. Which one do I want to do? The strongly selected epitope. And try to load it in. I will tell you, I'm going to be impressed if anyone gets this. So here's what this data set, oh, I'm looking at the wrong screen. Sorry. So I will tell you that it took me probably at least an hour to get this data set loaded. And that was starting from notes that Janice gave me from last year when she taught this lesson. And I wanted to do things the way I like to do it. So I had her code as guidance. So I didn't even have to really think too much about what problems needed to be solved. I just had to think about how I wanted to solve the problem. So I don't expect anyone to actually necessarily get this parsed in 15 minutes, but I think it's worth struggling a little bit. So before I let you go, can we talk a little bit about what the heck's wrong with this spreadsheet? Any thoughts on what's wrong with this spreadsheet?
At least on the titles, they're separated, so how is that going to enter in?
Here, the headers?
Does that matter when it enters in? It seems like it would.
Yeah, it's a little bit of a problem. We're used to having the header all on one row. So first column's good, right? Got days post-infection. That looks nice, mostly. There's an issue there, but I'll leave that for you to play with later. Yeah, so we have this first row here, actually, that's magnitude of CTL responses, which is just the header for the whole thing. It's, that's basically the title for the spreadsheet. I don't know why they put it there. And then we've got these 2 rows per, so this is actually these two parts here combined are the header, but it's split into 2 rows. And then we got data. The data is mostly okay, except for the fact that we got some missing values, but that's, that's the least of our problems.
Then you got that little guy down at the bottom.
I wasn't going to mention that, but yeah, the little guy down at the bottom, this right here, right? That tells us that DPS is days post onset of acute symptoms. Yep, that's actually,
I don't know what it looks like when it goes in.
that's the least. Yeah, no, it's a problem, but it's actually the least of your problems. So everyone understands. So what, do you want me to tell you what I think you should aim for? Or do you want me to just leave that for you to struggle with? I'll tell you what you should aim for. So like I said, these 2 rows in this column, that's actually the header, the whole thing. So really you want this to be, it doesn't need to be on 2 different lines, but you want that smushed together, right? You want to concatenate this and this as the header for what here is column B, this and this as the header for column C. And then, you don't want this DPS here as the column header there. Then load all this and yeah, well, I think I'll stop there. So 235, let's say. Is that enough time for at least a break and to bang your head against this a little bit? And again, I'm not expecting you to, I'm going to be super impressed if anyone actually gets this loaded in a normal data frame, because I don't think I could have done that in that amount of time. But I feel like it's kind of nice to struggle a little bit. What doesn't kill you makes you stronger, mostly. Did everyone figure this out? And I shouldn't waste your time going through it. Move on to the next thing. did anyone make any progress that they want to comment on?
I think I have it mostly depending on what you want to do for days or how the columns should look.
Okay, cool. Do you want to?
I mean, I probably didn't do it the way you do it, basically something that here, but, basically, first you read it in, read Excel. And then, yeah, you would, choose the types of.
Yeah, let me,
Well, actually, I didn't do it that way. I changed it that way. But, right, so you read it in, and then what I did was I took the, because basically when you read it in, the column names are all messed up, so you just place the column names in order with the first row. And then, basically just pasted in addition to that, the string that is the second row. That gives you, all the information there for the first row, which column.
okay, here's the first.
Yeah, I mean, you can't follow what I'm saying.
Yeah. No, yeah. So, do you want to show, or should I just show
I
what?
don't think I can actually, yeah.
Okay. Anyone else have make progress? Okay, so let's do this like bit by bit. Actually, I'm gonna skip that part for now. Okay, so if we just try and read it in like that, we have this kind of mess. First column is DPS, so that's good. Then like the next column is magnitude of CTL responses. It's that like sort of header that we have at the top. And then like everything else is just like an empty header. And then these like, what we really want is the header rows are values here. So then everything's a character, right? Okay, so that's not so good. So let's try playing with this a little bit. So we can do strong selected path, read Excel. So first of all, like this first thing, we can just get rid of this first thing. We don't need it. Like that gives us no value. I mean, it helps us to know that like the values here, the magnitude of the CTL response in SFC is spot forming cells. It's the assay that they used was a LE spot, which I can try to explain, but I probably wouldn't do a very good job. But yeah, so that's what these values are, but we don't actually need it for loading it into a data frame. So the first thing we're going to do is we're going to say skip equals 1, which is going to say like skip the first row, don't bother to read it. So that helps. That gets us like this first part of the header here. We've lost our DPS, but that's okay because we can just plug that in later. We still have the second row of the header there. So that's kind of a mess. We can do really what we're going to ultimately, the way I approached it was to like pull out the header, and this, I stole the strategy from Janice, but pull out the header, deal with the header, and then like glue it all back together later. And so to just like grab the header, we can do this, n max equals 2, which is saying just read in, so we're skipping the first row. So when you skip the first row, it's gone. So n max equals 2 means like just read in 2 rows, which is going to be the next 2 rows, those 2 rows of the header. And so we're going to get this, right? So it's just header. Oh no, that didn't work. Oh, because it's reading this as a header. How did I? That's weird. I think I'll get rid of that skip equals 1. There. See, now we just have our DPS and we got these as headers and we got this weird like super header thing here, but that's okay. Okay, so that's part of what we want. We'd kind of like to just like get rid of the DPS row here. And so we'll deal with that in a second. Actually, I think what we want to do, if we want to have the skip thing there, is we can do call names equals false. Does that work for us? Yeah. Okay, that's what we wanted. I don't know what I was doing before that worked. Anyway, okay. So that's part of what we can do. So we can take that a step further, and we can just get rid of that. Oh no, that actually works for us. We don't need to do anything else. Is that right? Yeah. Interesting. I don't know why this worked. Okay. So, you know, another option would have been, oh, I know why. Okay. So another way to skin this cat, no offense to people who love cats, strong selected path, read Excel, is that we could say skip one, and we could give it a range of cells to get. Now, this doesn't cooperate with the, well, I'll show you. We do that n max equals to, so we're telling it a range of cells. We're giving it like rows B through I. So now we have, we're getting rid of that DPS column, but it doesn't play well with n max too. So you can see now we're like loading all the rows here. So that doesn't work exactly how we want it. So, but apparently we can just do it this way. And so we'll work from there. So next, what we want to do is, the easiest way I found to do this is like dealing with this as rows and like doing things like row to row. dplyr doesn't really work that way so much. It's much easier to do things like column to column. So what we can do is we can do transpose on this, which is just going to rotate it 90 degrees. In R, that's T. And so now we have what were columns there of like this sort of 2-column header. Now we have like the first part of the header as column 1 and the second part of the header in column 2. So like this goes with this, this goes with this, right? So now it's easy. Like dplyr likes to, and like R in general, is happy to do things like working on stuff from column A and column B in a data frame. So now, so transpose gives us back, we gave it I don't know if it's a data frame or a tibble, but whatever. Transpose is giving us a matrix. So that's all, which kind of makes sense because like normally transpose matrices, and often for a data frame, it doesn't make sense to transpose it, especially if you have like different columns or different types, right? If you had like a character column and a numeric column, transposing it, you can't really do that. It's gonna, I don't remember what happens, but it's gonna be enough. Here we can get away with it because they're both character columns. But we want it back as a tibble or a data frame. So we're gonna do as tibble. So now we have our nice transposed header as a tibble. Because we had a tibble and we didn't give it column names, it's just calling them B1 and B2. But that's okay. So next we can use a tidyr function called unite, which will cram together columns. So we have to tell it what we want this new column to be called. And I'm just gonna be totally uncreative and call it combined calls. and I need to give it a range or like tell it which columns to do. And here it's really simple. And there are other ways we could have done this, but I like this because it's very tidy burst. And so now we have the two columns stuck together, and by default, it's going to join the columns with an underscore. And I'm okay with that. We could change that later if we wanted, but that's good. So now we're mostly like what I asked for, right? We've got the header combined, there's 2 row headers combined into like actually a single string. Before I keep going, questions about that?
Can you just scroll back up to the?
Absolutely. I could actually even like move this up a little bit. I could put that much. There. One more space. Any other questions? People on Zoom can still hear me, right? Amy? Oh, yep. Okay, cool. Okay, keep going. Okay, so then the last thing I want to do is I actually want this as a vector, because I'm going to use it as an argument to call names. I'm going to run read Excel again and use this as an argument to call names. So the way I like to do that, because it's tidyversy, is to use the pull function, which pull grabs a column from a data frame and it makes it as a vector. Now, like here, it's kind of stupid because we have a 1 column data frame, but it's still like, I don't know, I feel like it's less ugly than doing it other ways, which are more like base R things to do. So now we have a problem. Combined. Like, did I misspell this? Combined calls not found. Where it's there. Combined calls. Call. There, it worked that time. I don't know why it didn't work first time. Okay, so now I got it as a vector. I'm just gonna assign that to epitope header, and there we go. Okay, so now we're like kind of, that was the hard part. Now we can just do, it's pretty much what we did for the simple one. We're gonna load this again. Sorry, strongly selected path, read Excel. So one thing we're gonna do different this time, what are we gonna say for skip? Three, because we have that first funky one, and then we're going to skip the 2 rows of the header because we've already pulled those in as a separate vector, and so we're going to skip 3. For call names, we're going to give it this vector, but I would have forgotten this if I didn't have my notes here. Remember, we like kind of trashed that first column, the DPS column, so we need to add that back in. Epitope header. So now this is going to like make a new vector that has DPS at the beginning and then the epitope header part. And then we got one last thing, which is we want to, well, let's do it like this. Why is this? Oh, because I don't have a comma there. Okay, so that looks good so far. Other than the fact that we have a super long header name, it looks good. That looks good. That looks good. You can see we've got some NAs here. Remember, there were some blanks in the there's some blanks in the spreadsheet. That's just, that's what NAs are for. That one looks good. That one looks good. That one looks good. That one looks good. Okay, so everything's good. Anyone notice any problem?
DPS column, no characters.
DPS column still characters. Why is the DPS column characters?
You pulled it out and you did everything.
Nope.
Oh, no?
Nope. Because that was, because we just reloaded everything except the header.
The little friend.
Yeah. Remember here, the little note that we had? So that's still in that column, right? And so it's saying, oh, you got a column there. And actually, if I'd scrolled to the bottom, then it would have been obvious, right? Because it loaded those last two rows and loaded that as a value. So we don't really want that. So there are a couple different ways we can deal with that. I'm gonna be like a little bit lazy here and just do it like this and do call types numeric again. And did that solve our problem?
We still have 2 rows at the end.
We still have 2 rows at the end. Yeah, I partially solved the problem, but I didn't totally get rid of it. And I will point out that, when you do things like this, you'll get the console popping up there. It was a good idea to check that, because when you ignore it, you do that at your peril. And it is saying expecting numeric got DPS, days post onset of acute symptoms, right? So, okay, that's fine. It's a warning. That's fine. We're just like coercing that to numeric, which results in an NA because it can't coerce text like words as to a numeric. That's fine. So then the last thing that we'll do is we can just filter out this row. And so there are different ways we could do this, but one way is we can say like, okay, well, those rows, they have NAs in the DPS column. Like some of these values there, NAs like scattered around, but that's the only one that has NAs in the DPS column. So we just filter on NAs in the DPS column and kind of call it a day on that. Okay, so filter. Not is NA DPS. So that's gonna filter. I always find this confusing, but filter, you're selecting 4 things. So here we're selecting 4 rows in the DPS column that are not NA. So when we run that, now our DPS is doubles. Oops, I'm doing it the wrong way. And if we go to the third set here, now we don't have a DPS, an NA, a couple of NA rows here. So are we good? Anything else? It should be the same warning. It's that we're like explicitly making that all of the columns numeric, and it's telling us, we're basically like silently throwing away this text that's not numeric, and that it was expecting a numeric value. There are other ways to do it that maybe are a little cleaner, but the data is kind of yucky. So, it's not yucky. It's just like the formatting. Anything else? Yes and no. So I'm happy with this, except we're actually like now, like we're just printing the data frame, and we probably want to assign it to a variable so that we can use it in a second. Strongly selected data frame. And then now we can plot it. Go down here. Okay, so, oops. With the data frame, I'm going to do the same sort of thing that we did before. We're going to pivot it longer. Calls equals. So we're going to you grab all the columns except the DPS column, names to epitope, and the values to CTL, because remember this is like the cytotoxic lymphocytes. Did we talk about what this data is? I can't remember. I think I maybe like glossed over it. Okay, I'll spend 2 minutes. I kind of talked about it at the beginning, but I didn't really explain it. So each of the columns here is a different viral epitope that I think all of these are like epitopes that are present in, so it's protein sequences that I think are all present in the initial viral sequence. And then each of these epitopes was tested in a, like the cytotoxic T cells were purified from the blood of this subject and tested for how strongly they respond to each of these epitopes. Then the numbers here are like basically the strength of the response. So you can imagine 0 is 0, like there's basically no response. And then you get like, obviously some higher numbers. And this is a subset of all the epitopes that they tested, and it's called strongly selected because these were actually epitopes for which there was like strong immune system or evolutionary selection on the virus. Like these were like epitopes that the immune system were like, woo, this is like, we need to like find these guys and kill them. And so the virus evolved away from having these epitopes pretty quickly, like on viral timescales, right? So like, for example, you can see for a lot of these, like for this one, by day 491, there's like no lymphocytes that are recognizing this. I don't know what happened out here. And maybe if I read the paper more carefully, it would explain. But I don't know why it's popping back up again. Maybe because the virus is like actually shifting back to that epitope or something. But you can see that kind of like all of these, there's like a strong response early on, and then the immune system it isn't recognizing it. And the figure in the paper, which if I have it open, not that one. This is the figure that I showed you at the beginning, where you can see like the virus with that epitope. You're not seeing those epitopes anymore. It's these top 2 rows. The virus sort of like disappear, or the viruses with that epitope disappear because like the immune system's gone after them and like driven those specific viral sequences to extinction basically within this individual. Which is what you expect based on evolutionary theory, but it's kind of cool to see. So yeah, so that's what the data is. And then each row is a, different sampling time point. That makes sense? Questions about that? Okay, so we're gonna pivot this longer, right? Now we have by epitope and days post symptoms, and let's plot that. ggplot. We'll make the x-axis days post-infection, or days post-symptoms, and the y-axis is the CTL, and we can color it by the specific epitopes of the columns. And let's start off by doing a scatter plot. Oops, didn't like that. What did I do wrong? Oh, because it's not a pipeline. Okay, so there's a little warning message here. 75 rows contain missing values. We already knew that, right? There are a bunch of NAs. So happy with this plot? Great, ready to publish? Any like criticism? None? Great, ready to publish. Call it a day. Really?
Well, maybe the stretching it first, just to see the color.
Yeah, it's like all squished here, right? Why is it all squished?
Legend too big.
Yeah, because like these epitope names are like crazy big. Any other problem with that?
Well, the deep.
I think even if I stretch it out, like this is just like a big mess of colored points. I don't think that's super important. So let's try a little harder. Let's do the same trick that we've done before. Let's facet it on epitopes. Oh, it doesn't like that. Picky, picky, picky. Close enough. Okay. Better?
You show like percent of each episode.
I could do that. Although I don't know if I need to. I don't think that's the, so that's not, I don't think that's the biggest problem. I think number one problem is we still got this big ugly legend here. So let's do the same thing we did before, which is choose theme, legend, because we don't need the legend anymore, right? Because we faceted it. None. How's that? That's pretty good. Perfect.
The title's on.
Yeah, titles don't fit the boxes. Let's see if we can fix that. So one way we can fix that is we can say, okay, we only want 2 columns here instead of 3. Oh, it didn't like that. Oh, end call, not end calls. There. So that's better. Well, they mostly fit. We can also make it a little bit, how do I do this? Fig. All right, we can make that a little bit bigger. Actually, I don't know if it's going to fit anymore. That's kind of better. Make it 6. There, now they fit. I'm going to do the same thing that I did before, which is I don't like the background, the gray background. I think it's ugly and I understand why. That's the default. Now it's beautiful. Anything else? It's perfect, right? You can nicely see, so we're kind of, you know, I didn't add an line. I'm gonna be lazy about that. But you can, no, not that one. We're, you know, we're doing actually like a decent job of replicating these figures. Not the green part, but the red part. If we added a line, it'd totally be perfect. Actually, I'm gonna do the other thing that I did before, which is now that we have facets, get rid of the color. We don't need it. But you can see like the epitopes are kind of tend to peak, you know, some not as high as others, but they like peak early and then they like tail off as the virus shifts away from those epitopes. That's cool. Anything else we should do? Ah, fine. How do we do a name? Plus, was it GG title? Awesome. Yeah. There, got a name. I'm gonna go with this one. Okay, so there are two things that we can do now. Actually, maybe I'll assign them both to you. So one is that there are some other files that have this format with a like 2-row header. So you can dig those out and you can try and run those yourself. And the other thing that you can do, which maybe I'll think while I'm telling you. Okay, so there's another ugly format here, which is, it's the variant M is the example that we're going to use. Okay, so what's wrong with this data? This variant ends epitopes.
All the borders gonna have to look.
Hmm? What'd you say?
Are the borders gonna, look like they might cause some
The the black lines?
problems? Yeah.
Nah, read Excel doesn't care about that.
Oh, okay, so it doesn't.
I think that so there are, I can't remember read Excel. You can get formatting from Excel spreads. There's some packages that will actually let you get like pull formatting out of Excel spreadsheets. I can't remember if read Excel does, but we can just ignore it. It's not gonna. Although I don't know if maybe you're saying something different, or maybe what you mean is something different than what I'm hearing. But the lines themselves aren't a problem. This like outline here.
So you'd wanna split the data so that you have original versus variant, would you?
Well, maybe not. So there are different ways to deal with it, but yeah, so this is, these are all variants, right? And so there are different ways to deal with it, but anyone know what this is called? Where like this variant is a label for all of these things. This is a merge cell in Excel lingo. Here's a hint. Read Excel doesn't deal with that very well. I'll let you play with it a little bit and see what it does. But I'm gonna, so so like some of this looks like what we saw before, right? So some of these, it's actually like kind of a mess, right? Because some of these are, it's 2-row, some of them are 1-row. But then we actually want to incorporate, what I ultimately did was I actually made it so that the variant, the header is original, like basically like these 3 rows combined. So original, this, and this. And then for each of the variant rows, I made it variant and then the like specific epitope. And I think that's most of the issues with it, but it is more complicated. I will give you another hint. Well, I already told you, Read Excel doesn't deal with this in any way nicely that I could figure out. There are other packages that do. So maybe, how about 315? How about maybe let's take 10 minutes, and you can either, after the 10 minutes, well, I guess we can see, but I can walk through how I parse this. So you have a choice. You can try and solve this yourself. Again, this is like pretty tricky, or not super tricky, but I don't know, it took me a while to figure it out. And the other option is that you can look through and find other spreadsheets that are the same format as the 2-row version and try and parse those. So I'll leave that up to you, and we'll take those 3, let's say 325, so 12 minutes to kind of like, you know, have some R joy. Questions about that? And there are lots of different ways to deal with it, but the way that I was happy with, I did not end up using Read Excel. And you don't have to install any additional packages or any packages that aren't already installed in the environment that we're working in. Anyone not ready for me to go through how I tackled this? Oh, where'd my window go? Oh, wait, no. There. Okay. I'm not hearing any like loud objections. So, let's see, that there. Okay. So, so let's just start off simple and do what we did before, which is to use Read Excel. I'm assuming that everyone probably tried that. So here's what we get. We get DPS column looks okay. Kind of maybe, except we have a bunch of NAs here, which is going to be actually like the header for the rest of it. And then this isn't bad. So if you remember some of the here, like not all of them have like that sort of what was the second row of the header before. So that's kind of annoying. But the worst thing is that here, for those merge cells, so column 4, here is the column D here. It should be a variant, but if you look and see what Read Excel is doing, it's just making that an NA. So that's not good, because this should be variant. So like I said, I didn't find a nice way to do this with Read Excel. But thanks to Google, I found another option, which is there's another package, OpenXLX, which I think, if I remember correctly, Read Excel is actually like based on. Read Excel is a tidyverse package. OpenXLX, XLSX is not a tidyverse package, but I don't remember where it's from. I think it's just from some random person. But it has this nice mechanism to deal with merged cells, which is really actually pretty simple. And so we can do this. We actually already loaded the package at the top. I didn't mention it at the beginning, but it's one of the packages that we loaded here. Let's see. What's out there? Okay. So the function that we want from the OpenXLSX package is read.xlsx. And so we can just start with that. And that's gonna, I think, give us something pretty similar to what we got with Read Excel, right? We are getting these the merged cell is going to the first column of the merge, nothing else. But we can tell it to one of the options, and we can look at the help here. Read.xlsx. So one of the parameters for it is fill merge cells. And so that's basically gonna do what we want, like across a merge cell, it's gonna split up those cells, because there's no way to deal with there's no representation for merge cells within a data frame, but it's just gonna copy that across what were the merge cells. So if we say true, fill merge cells true, now we're getting here there's the first variant one, the next variant one is also filled. As a side effect, we're also getting the header, this magnitude of CTL responses is also being plugged into all the columns, which we don't necessarily want, but it doesn't matter because we're going to get rid of that anyway. As a matter of fact, let's do that now. So we can do call names equals false. And so now we're just getting, just giving us X1, X2, X3, right? It's still spreading that non-header header, but that's okay. We'll deal with that later. So this is actually pretty good. We've gotten solved a lot of our problem. It's still kind of a mess, but now we're sort of in the mess, pretty close to the mess that we had last time. So what we can do now is we can do what we did before, which is just pull out that header row and sort of refactor it and into a vector, and then we can use it to actually load reload the spreadsheet. Okay, so the first thing I'm going to do is I'm going to use a different way to grab out those the header rows that we care about. So I'm going to use the slice function, which I think is dplyr. Oh yeah, there it is, dplyr. And I'm going to say I want rows 2 through 4, which is the header rows. And so that's going to get rid of that magnitude, whatever, the thing that explains what the values in the table are. You'll notice actually that I didn't point this out before, but DPS is actually also it's merged vertically here. And so we're getting DPS filled in that column. We'll deal with that later. That's like kind of annoying, but it's not disastrous. So this is now looking very much like what we had before, right? We've extracted just the header. We've filled the merged column across, the merged like columns across, or the merged cells across the different columns or rows in the case of DPS. And so now we can just do that trick that we did before. We can transpose it and then convert it back to a tibble. And now we have our header as like kind of, you know, rotated 90 degrees. And we can do the same thing. We can use unite. No, I gotta do. So this is what the united column is going to be called. Combined calls. And here we actually have three columns, right? Because we have the original variant column also. And then we're gonna pull that into a vector. Combined calls. And so like pretty good. Is this awesome? Are we done? Well, okay, so fine. So we have to like actually reload this, but is this like beautiful? Everyone thinks it's amazing, perfect, we're all set. Like I know this is like, you know, pretty nice, but are there issues that anyone sees with any of this?
One of the like definition of the original one, then applies to different things.
Say that again?
Yeah, whenever there's an NA at the end, we probably want things that applies to, right?
So actually where there's NAs, it's actually NAs. It's because remember some of these, like this is different than a little bit different than the other one because like here, this one's split in two rows, but actually this one, it's kind of got those two parts.
I thought you wanted that one also on. Okay. Like, you know what I mean? Like
No, this actually is, I think this is specific for this, and this one's, I think that, so this is the, I think that this is actually the good question. That's not how I interpreted it, but
well, it's really hard to just attach it though, manually, if I can kind of do a floating thing. That's what I think is the hardest part.
yeah, no, I think that this is actually specific for this. And I think that this label is for, is specific for each one of those. Sorry, I didn't even think of that. I could be wrong. But yeah, that's not how I interpreted the data. Anything else? And I'll tell you the reason why is because it does have like ENV is a HIV protein, so this does have an ENV. I don't know. This is, I think, specifying amino acids, maybe like N5. I think it's like arginine in the 5th position. What's E? Alanine. Wait, is there any amino acid? I can't remember. I'm not sure what the DW means. It doesn't make sense for the DW, but yeah, that was how I interpret it. Okay, so any other So if that's wrong, then I didn't fix that. Any other like weird things with this? You're less picky than me. So I have like a whole list of things. One is that we got this DPS, DPS, DPS. Like that's weird, right? So I'd like to get rid of that. Two is that you've got this like trailing white space here, which is, you know, at best it's a little ugly. At worst, that can create problems for you because like it's sort of silent white space, which can be dangerous. We have these NAs here, which I don't want. We have like underscore NAs, and actually the unite is putting, here we have this like blank and then underscore, which is also weird. And so unite is putting in these underscores, but like that's kind of weird. So I'd like to get fixed all those things. And you know, like I'm being a little bit picky, but there's actually not too much work to fix that. So we can get rid of the NAs, that's pretty easy. We can just tell Unite that we want to do na.rm, which is remove NAs. So basically it's gonna silently kind of ignore NAs. And that's gonna get rid of, ooh, no, it didn't like that. NARM, oh, duh. Must be true or false. Okay. So actually, let me put it back how it was before so you can see the difference. Okay, so here we have those like underscore NAs, and now when we make NA, so that's the default. When we make it NARM true, now we got rid of our NAs. It's beautiful. That makes me feel good. No one else seems like enthusiastic about that. Oh well. Okay. So we still have these like weird things where it's like oh, did I not fix that? Oh well. We have these weird things where it's like an underscore space and then an underscore. So that we can also fix pretty easily, kind of, with sep equals. So by default, Unite is using underscore as a separator, but we can make it just a space. And so now we have, we've kind of like solved the problem, but it's sort of like silent. Now we have two spaces instead of a space underscore. Actually, I want to get rid of that for a second. Let's come back to that one. Because really the problem there is that here there's some white space here that we can't see. If you look here, it's hard to see, but come on, why won't you get, oh, because I have it highlighted, that's why you won't get bigger? Okay. So there's some white space here at that, it doesn't want to do it. There's a space there at the end there. And so that's getting concatenated in. So this is the Unite separator, and that's just some like random white space there. And that's why we're also getting this white space here and here and here, because there's white space there too. Which again, like silent white space can be dangerous. So I'm going to add in this function trim WS, and this is just like a base R function. And it trims like white space that's at the beginning or the end of a character vector. So now we've gotten rid of there's no white space at the end there. And here, where we've joined things, we don't have white space there. We just have the Unite separator. So that's good. And so now we can go back and we can make sep equals that, which is, I kind of want to do this because like in these guys, there's a just white space separating it. This is where it was already all on one line, and here there's like a underscore separating it, which is kind of inconsistent and weird, and maybe could create problems for us. So now, if we make the separator a space, then all of them have just like a space separator. And then the last thing that I didn't like was this. I think it's this last thing, or am I missing one thing? Is this DPS, DPS, DPS. And actually the easiest way for me to deal with that is going to be just to do a string replace. This is a function from string R, which is another tidyverse package. String replace DPS, DPS, DPS. And we're just going to replace that with DPS. And I think that's all the stuff that I didn't like. So now, is there anything else that people are like, oh, that's ugly? Fix it, please. No. So now let's make that a, no, not a path. And the epitope header. And now we can do the same thing we did before, which is we can actually load the data and use that as the column names. So now we can do m epitope path, and we can just use read Excel at this point, because our problem was with the header, but now we've like dealt with that. So we can just use read Excel. So we're gonna skip the first 4 lines, right? Because we had that like the weird like Uber header, and then the like 3 header lines. The call names we're gonna get from the m epitope header. We have this issue again of this DPS post onset of acute symptoms. Same thing. Oh no, wait. No, that's not the wrong one. Here we have this here, so we're going to make it numeric. I'm ready for a nap. And then here, we are gonna, oh no, did it work? What did we, oh no, it got rid of that. No, didn't, we're not at the last one. Yeah, so here we do have like the NAs here, so we could do it again what we did before, or we can which is like filtering just on the NAs in the DPS column, or we could also do we could also say okay, well, let's just filter anything that where the whole row is NAs. So another way to do that is if any everything is not NA dot, and this, I knew what I wanted to do, but I needed to Google to find a way to do it in a dplyr-ish way. I didn't like it.
Stick it in the arrow.
No, it's not, it shouldn't be the arrow. This one? I'm doing it right. Oh, maybe. I think. Oh yeah, I guess you're right. It's getting ahead of itself. Okay. And so now, oh no, I didn't like that. With this? Okay, fine. I'm gonna get rid of my fancy thing. I'm just say filter not is in a CPS. That works too. Okay. So it is 3:57. I think I'm going to call it a day because I'm supposed to remind you to, where'd it go? I'm supposed to remind you to fill out the, come on, the survey for feedback. It is here, I think. There, and I think it's already in Zoom. I will not try to, unless anyone wants me to give you the full link, I'm not going to put it up there because nobody wants to type that. Any questions? And I will say that, so this is the last session in part 1 of the workshop series. We are starting part 2 sometime in January, like maybe the first or second week in January. And I'm pretty sure registration is open. I don't know if you all got emails. So the part 2 is another 6 workshops focusing on statistics. I can show you where to find it. If you Google for CFAR Duke, the first thing that comes up is the Duke CFAR page. And if you go to training opportunities, I remember actually. Wait, training. No, maybe it is this quantitative methods in HIV. Oh yeah, here. Okay. And you go to workshops. But maybe there isn't a link. I'm pretty sure this. Do you know, Janice? Do you know if it's? I think the application's open. I feel like I remember there's an email about it.
I don't know.
Okay, hold on.
So do we have to register again?
So I think so, because I think that for the registration when it was open, I mean, I think that the registration opened like a couple of weeks ago. It's possible I'm wrong and it's not open. Yeah.
I don't know if far emailing this, I do not remember getting an email about it, but that does not mean I did not get an email about it.
Okay, well, let me, I'm probably not going to get an answer right now, but let me check with Kelly, who's the contact person anyway. Okay, maybe not. Maybe I'm imagining it. I could have sworn that I mean, I will say that there's like another, I'm also involved in a summer course that we have started announcing. So like those things could be confused in my brain.
I have a question. If you've signed up for the class through Duke Hub, do you also need to sign up? Is there a separate sign up for the workshop or is it implied?
So the, for the spring, for the part 2,
Yes.
we'll contact people and let you know. I'm not sure. But for everyone who's registered, for the class, we'll let you know.
Okay, perfect. Thank you.
Okay, so if you've done that, I will make sure that when I hear back about whether registration's open, I will ask if it is not open now, if when it opens, to be sure that it actually goes out to everyone who was registered for this session. You can see the topics are actually here for part 2, and the dates are here too. Although I'm not teaching any of them, so I'm not really paying attention to the dates. Yep, but I will. If registration isn't open, I'll make sure that. Well, anyway, I'll make sure that if registration is open, then the list will be sure to send the registration out soon, in the next couple of days, to the list for people who are registered for these workshops. If it's not open, once it is open, we'll get it sent out to people who have registered for one or more of this series of workshops. And otherwise, if there aren't any questions, happy Thanksgiving. Like I said, I'm not teaching part 2, but I will be back for part 3, which is going to be in the spring. So if you want to hear about high-throughput sequence, how it's generated, how to analyze it, how to analyze RNA-seq, microbiome data, single-cell RNA-seq, then I'll be here for that. And someone else will be talking about flow cytometry data, not me. Okay. Well, thanks for coming. Have a good Thanksgiving.
Thank you.
Thanks for spending the afternoon in a dark and subterranean classroom with us.